Hello everyone, good evening. Welcome back to this session on motion in straight line topic. So if you remember, we had seen the straight line concepts, the kinematics laws of motion a couple of weeks, and then the last class, if you remember, we had seen the motion under gravity, where we had discussed different concepts, different problems in that. And before we start off, I hope you all had a good exam and then good Ganesh Nimarjan and all. Firstly, happy or belated rather, I will say, Vinayak Chaturthi and all, because we couldn't meet last week. So I hope you had a good time in the weekends, Friday, Saturday, Sunday, and also. Now coming back to this topic, there are a couple of problems we will solve. Very simple problems in the initial concept that we have seen. Couple of problems with respect to the previous year's papers that we had got. I mean, couple of questions where previous years they had given the questions on this. That is what we will see for now. We will see those questions, and then we will move towards one of the most important concepts, and you can definitely expect one question with respect to the to this concept. Definitely you can expect one. That is what we call the relative velocity concept. So we will see a couple of relative velocity concepts and all. So before we start off, like usual, let us go do couple of problems of previous year's question papers, and then we will go to that concept. Okay, so I hope you've gone through all this previous classes concepts, you have understood. If you've not, do let me know in the comments box or chat box. We'll definitely discuss that. And hope you've gone through all the formulas and the different conditions under which, or scenarios, what I would like to call scenarios, in which you can apply this concepts of, say, your loss unit and I mean your formulas, and then different scenarios where you have applied different formulas. If you remember, I've told you that there are five parameters, and you have three formulas which use four parameters any time. In the questions, you will be given three, and you will be asked to find the fourth. So based on the formula, based on the parameters that the questions ask you, you are supposed to use that, pick and choose the formula whichever is fitting that, to find out that answer. Okay, now let us go ahead and see couple of previous years problems. Okay, and if you want to see this, I'll just take down this questions. Okay, just take this down. So this is one of the previous years NEET papers, etc. So one of the question is, it talks about this thing wherein uh, the velocity value is given. So let me write it down for you. The velocity of a particle, okay, velocity of a particle is nothing but at plus bt square. Okay, velocity of the particle is nothing but at plus bt square. Then you are supposed to find out the distance traveled distance traveled by it by it between first second and the second seconds. Okay, you are supposed to travel you're supposed to travel you're supposed to find out the distance traveled by it between the first 1 2 seconds. Okay, now we all know, when you have v is nothing but at plus bt square. Sorry, it is at plus bt square. Okay, simple concept. If you remember what we have seen, velocity is nothing but at plus bt square. Your v is nothing but dx by dt, correct? Now if the velocity is given to you, to find out x, or the distance or displacement, however you call it, okay, you are supposed to integrate it. If you are supposed to find out the acceleration, you are supposed to differentiate it, correct? So now this becomes one of the simplest answers. Okay, now you integrate this. Okay, you integrate, your s is nothing but v dt, integral v dt, which is nothing but, now from where to where do you integrate it? From the limits will be, the lower limit will be 1 and the higher limit will be 2, correct? So 1 to 2. Now what is velocity given? At plus bt square, correct? At plus bt square dt, integral 1 to 2, correct? Now what is integral of at? What is integral of at? What is integral of at? It is nothing but at square by 2, correct? What is integral of bt square? It is nothing but bt cube by 3, correct? And what is the limits that you're talking about? 1 to 2, correct? Integral 1 to 2, clear? So now this becomes a into 2 square by 2 plus b into 2 cube by 3 minus minus a into 1 square by 2 plus b into 1 cube by 3, correct? You agree with this? You agree with this? So what happens to this? What happens to this? This is nothing but 2a plus 8b by 3, because 2 cube is 8, minus a by 2, okay, minus b by 3, minus b by 3, correct? Clear? So now this will be nothing but 3a by 2, 3a by 2 plus 7b by 3, 3a by 2 plus 7b by 3. Clear? Now this is the answer. This is the answer. You understood the concept? This is 2016 question. This is 2016 question. Clear? Simple concept. You are given v. You are asked to find out s between two intervals of time. That is 1 and 2. So you integrate it. Put the in lower limits of 1 and 2, and then you can start. Clear? Okay. Now, similarly, in the similar line, let's say we have another question. Okay. Let's in the similar way. Let's see, we have another question wherein there are two cars. Okay. There are two cars. There are two cars P and Q. Two cars P and Q start from a point at the same time. Okay. They start from a point at the same time. Start from a point at the same time and start from the point at the same time in straight line. Okay, let's say it's all in the straight line. Okay, and their positions are with respect to time is given as at plus bt square. Okay, positions, and xq is nothing but ft minus t square. Okay, okay. Now what is that they have given you? They have given you the positions of these two cars as a function of time. As a function of time. Clear? They have given that the position of the car P in terms of distance or displacement is nothing but at plus bt square, and the position or the function of distance or displacement of the car Q with respect to time is nothing but ft minus t square. Okay. Now the question asked is, at what time, at what time do these cars do these cars have same velocity, have same velocity? At what time do these cars have same velocity? Okay, clear? Now the moment you talk about velocity, x is given to you, velocity you are asked to find out. What is that you do? V is nothing but dx by dt, correct? So in this it changes to xp. Okay, okay, let me write it once again for you. dxp by dt, which is nothing but at plus bt square. Sorry, it is 80. Okay, 80 plus bt square. Okay, differential with respect to time dt. Clear? Understood? Now what happens? Differential of 80 is nothing but a plus bt square is nothing but 2bt, correct? 2bt, correct? Clear? Understood? Now what is the velocity of q? What is the velocity of car q? V is nothing but dx by dt. Similarly there as well, here it changes to dx cube by dt. correct, which is ft minus t square by dt, which is, now what is the differential of ft? You only have f, correct, and what is the differential of t square? You have, it is 2t, so it is nothing but minus 2t. Okay, now what are we equating this with? This is velocity of vp, okay, which is nothing but velocity of car p, and this is nothing but velocity of car q, correct. So question asked is, at what time do these cars have same velocity? So same velocity, that means what? Your vp is nothing but vq, which implies at what time the velocities become same? Okay, vp is nothing but 2 plus 2bt is nothing but vq is f minus 2t, correct. So this is t into 2b plus 2, which is equal to f minus a. Therefore time is nothing but, at what time do these have the same velocity, is nothing but time, okay, t is nothing but f minus a divided by 2 into b plus 1. Okay, at this time, both these cars have same velocity, clear, understood. So this is also again a previous 2016 problem. I think it is NEET or AIPMT. I'm not sure of the which paper or which entrance exam, but either of this. So the concept or the idea is, given velocity, you integrate it to find distance or displacement. In our terms, we integrate it to find the displacement, we differentiate it to find the acceleration. Now given displacement, you differentiate it to find out the velocity. Further on differentiation of velocity, you get acceleration. Clear? It's simple as that. X is given as a function of time. Here also x is given as function of time. We are supposed to find out the velocity. Velocity is nothing but dx by dt. Clear? Got it? Understood the idea. Now similarly, let's take one more example and let's forward it further. Say example, uh, again I have one more question for you. So let's say I have a particle, okay, which is traveling in a straight line under the graph of 8 plus 12t minus t cube. Okay, 8 plus 12t minus t cube. Okay, this is the equation, or this is the function of that displacement with respect to time, correct. Now you are supposed to find out what is the retardation of this particle when velocity is 0. Okay, what is the retardation of this particle when velocity is 0? Now clearly you know retardation is nothing but negative of acceleration, correct. Negative of acceleration, r is nothing but negative a. It's as simple as that. Okay, it is not even a difference in magnitude, it's just the change in direction, as simple as that. Okay, now what is that the question is given to you? What is that the question is given to you? They have given you a particle wherein the function of time is given, correct. Function of time is given, okay, with respect to distance. Now you are supposed to find out retardation when velocity is 0. Now from this equation straightly you can find out the velocity equation, which is nothing but v is nothing but dx by dt, correct, which is nothing but 8 plus 12t minus t cube divided by dt, correct, as simple as that. Now what is the differentiation of 8? Constant 0. 12t is nothing but 12, and t cube is nothing but 3t square, so it is 12 minus 3t square, correct. Now this is my velocity. Now you all know acceleration is nothing but what? dv by dt, clear. Now further if I differentiate this, that is when I get the acceleration. So what is the differential of 12 minus 3t square by dt, which is nothing but 12, the constant, so it is 0, minus 3t square, it is minus 60. Clear? So this is my acceleration. Clear? So the given question is, find the what is the retardation, or find the retardation when velocity is 0. Now that means the only dependency to find out the retardation is time. So you have to get the time at what point when velocity is 0. Correct? When velocity is 0, v is 0, that means what? 12 minus 3t square is 0. So therefore at t square is nothing but 12 minus 3, which is 4, therefore time is 2. Excuse me. So velocity is 0 when time is 2 seconds. Clear? Velocity is 0 when time is 2 seconds. Now when time is 2, they have asked you to excuse they have asked you to find the retardation. Clear? So retardation, r is nothing but 6 into 2, which is nothing but 1. 12 meters per second square. Okay, so this is your retardation. So you've understood, if you've keenly looked at the concept, it is nothing but x, you differentiate, you get v, you differentiate, you get a, that is acceleration. Okay, differential acceleration, you do integration, you get v, integration, you get x. As simple as that. Clear? Understood the concept? Okay, any doubts? Any doubts? Go through this. It's a simple integration and differential formulas that we have seen. Okay, clear? Okay, now you can have multiple scenarios in this, multiple questions in this. How do you differentiate, how do you integrate with respect to the concepts of what is given and what is not given. Okay, okay. Now, so there is one important concept which probably used in one of the papers. So again, like I told you, this is also a previous year's papers in 2015, I guess. So one more question, let's see, before we go to the concept of relative velocity. One more question is, uh, let's say I have a velocity of particle. Okay, velocity of particle is nothing but beta. Okay, velocity of particle is beta x to the power minus 2n. Okay, where beta and n are constants, where beta and n are constants. Now you are supposed to find acceleration as a function of beta and n. Okay, you are supposed to find acceleration, or a in this case, as a function of beta and n, as a function of beta and n. Okay, how will you do this? Now remember carefully, the velocity, if you differentiate it, you get acceleration, but you are supposed to differentiate it with respect to time. Here you do not have any formula or any parameter in time. Here v is nothing but beta x power 2n, where your x is nothing but displacement, where x is displacement. Okay, how do you do this? In the earlier classes, if you've seen, I have clearly told you that one of the important things is nothing but acceleration is, when I say acceleration is dv by dt, this I'm expressing it in terms of velocity and time. Similarly, if I have to write it in simple x and x and v terms, what is that I do? Acceleration is nothing but dv by dt. Correct? I can simply say dv is nothing but dx into dx by dt. Correct? This is nothing but velocity is nothing but d dv by dx into dx by dt. Okay, I have introduced the dx, which is nothing but dx by dt is what? V. Okay, dv by dx. Okay, so acceleration in terms of velocity and displacement is nothing but v into dv by dx. Okay, remember this. So what you do is you differentiate this with respect to x and then multiply with respect to v to find the acceleration. So v is nothing but beta x bar minus 2n. Correct? Correct. Now dv by dx is nothing but, how do I differentiate this? Beta minus 2n comes here, x bar 2n minus 1. Correct? Into okay, into velocity gives me acceleration, because acceleration is nothing but v dv by dx. Acceleration is nothing but v dv by dx. Correct? Okay, multiply this with beta, which is nothing but beta x 2 power minus n into beta minus 2n x power 2n minus 1. Okay, this is nothing but 2n, I've taken it outside. Beta into beta is beta square, x power minus 4n minus 1. So this is your acceleration in terms of n and beta, which is what is the question. Clear? Understood? So the most important concept is expressing the acceleration, in terms of v and x. If you can express this concept, if it strikes you, it's a simple plain old integral calculus formula, plain old integral calculus, nothing more than this. Clear? So do not do the mistake of directly integrating or differentiating with respect to t, because it is not expressed in terms of time t. Only if it is with respect to t, that is where you use this. Okay, dv by dt. If the function is given in terms of time, it's a simple straightforward answer. Because it is not, that is where we'll have to convert this acceleration in terms of v and x. Okay, because it is not, you're supposed to convert the acceleration in terms of v and x. Clear? Understood? Okay, so now let's go on to the next concept. Now we will see one of the most important concepts or different kind of problems you must have already seen, or you must already have an idea of. The most important concept is relative velocity. Okay, relative velocity. Now you have different kinds of problems in this. You have uh, police and thief. Okay, you have river and boat. Okay, and then the third variety of concepts that you can get is rain man. Okay, you have rain coming in, then you have your umbrella. Okay, all these concepts fundamentally depend on your relative. Okay, all these concepts fundamentally depend upon your relative velocity. Clear? Okay, all this fundamentally they depend upon relative velocity. Okay, so now what is relative velocity? There are a couple of things that you have to clearly understand, and it's as simple as that. Okay, couple of things. Now coming to relative velocity, okay, it is not just relative to velocity, it can be relative acceleration, it can be relative displacement, etc. The idea is, it is all about relative motion. Okay, the idea is relative motion. Because you have a motion, you get displacement, you get acceleration, you get velocity. Okay, because you have a motion, you can get relative displacement, you can get relative acceleration, you can get relative velocity. Clear? Understood? Now the most important thing is, to find out or to understand the concept is frame of reference. Frame of reference. Okay, frame of reference. Okay, frame of reference. On which frame of reference are you observing to get the relative velocity? On which frame of reference are you observing to get the relative velocity derived? Okay, it's as simple as that. Once you fix the frame of reference with respect to the observers or the spectators, etc., you do that, your problems are solved. You do that, your problems are solved. It's then a plain velocity, differential velocity games. Okay, difference of velocities, that is what you do it. Okay, as simple as that. Now let me see, say example, in all the cases, in most of the cases you must have seen while traveling in while traveling in trains. Okay, while traveling in trains, if you're, say this is platform 1, if you're sitting in opposite platforms, okay, if you're sitting in opposite platforms, okay, if you're sitting in opposite platforms, say let's say this is train 1, this is train 2. Okay, this is train 1 and this is train 2. What is the most important thing? What is the most important thing is frame of reference. Now if you are sitting in this, if you are sitting in this train and observing this train moving, okay, assume this train is moving this side. If you are sitting in this train and your train is, even though it is at rest, you will still feel that your train is also moving. Your train is also moving. I hope you have definitely felt this phenomenon. You will feel that this train, if this train is moving while you are watching from the reference, from the frame of reference of train, you will feel that your train is also moving. Why? It is exactly because of relative velocity. Okay, it is exactly because of relative velocity. Okay, now if you are on the ground, if you are on the platform, if you are in the platform and you are observing this train, you will only see the train moving. You will only see this train moving. Again, why? Because the frame of reference that you have taken here is ground. Clear? Understood? If you differentiate, if you understand this very well, if you understand this very well, okay, your life becomes easier. Okay, with respect to relative velocity, your life becomes very simple, very easy with respect to relative velocity problems. All you have to understand is who is the observer or which frame of reference. Because I am the observer. Okay, I am the observer. In the first case, my frame of reference was train. My frame of reference was train, therefore I feel I am also moving along with this train. Okay, in the second case, the observer frame of reference is nothing but ground. I am sitting here. That is why I will only see the train moving while I am stationary. Okay, I will only see the train moving while I am stationary. Okay, clear? Understood? Now how do we derive this? How do we derive this? The equations are pretty simple. The equations is nothing. I mean, it's actually one simple concept that you have. Let's say you have a train that it is moving and a person is here inside this, and you are here. Okay, you are here and you are the observer. You are the observer, and let's say okay, you are the observer, and let's say the velocity of this, the velocity of this is nothing but v. Okay, and velocity of this is vb. Okay, I am also moving. Velocity of this is vb. Okay, it is nothing but, it is nothing but, okay, I am observing from the from the point of observer, that is from the point of b, and this is a. From the frame of reference of b, from the frame of reference of b, velocity of a with respect to b is nothing but velocity of a minus velocity of, clear? Velocity of a with respect to b, because I am the observer. I am the observer. Velocity of a with respect to b, velocity of a with respect to b is nothing but velocity of a minus velocity of b. Now with respect to, when I say velocity of a, it is nothing but velocity of a with respect to ground, velocity of b with respect to ground. As simple as this. Velocity of a with respect to b is nothing but velocity of a minus velocity of b. The moment you change the observer, so that means, let's say if I am talking about velocity, I have made this as observer. Okay, my velocity of a as observer. So that means what? I am observing from a, I want to see b. So that means velocity of b with respect to a is nothing but velocity of B minus velocity of A. Velocity of B minus velocity of A. Clear? As simple as that. As simple as that. Okay, again, this is velocity of B with respect to ground minus velocity of A with respect to ground. Clear? Okay, this is B with respect to A. Because here in the second scenario, in this scenario, the observer is A. Okay, the observer is A. In the first scenario where we are observing velocity of A with respect to B, the observer is B. Where you are observing with respect to B, the velocity of B, you are observing with respect to B, this is the observer, you are finding the velocity of A. Clear? It's as simple as that. Now similarly, in the same dimension, let's say I am observing here, I am a person, I have a, you can call it a train, bus, whatever you say. Idea is, if this is A and I am B, okay, and I am the observer. Similarly, I can have the acceleration concept also. Acceleration of B, oh sorry, acceleration of A, and if this is acceleration of B, acceleration of A with respect to B is nothing but acceleration of A minus acceleration of acceleration of A minus acceleration of B. Clear? Understood? Acceleration of A minus acceleration of B. Because the observer is B here, I am talking about acceleration of A with respect to B. Similarly, if I reverse this, if I am saying that my observer plane or frame of reference is A, then it becomes nothing but acceleration of B with respect to A. So I'll find out acceleration of B minus acceleration of B minus acceleration of. Clear? Understood? Okay, it's very simple formula. All you have to keep note or keep track of is who is the observer, what is the frame of reference, from which frame of reference that you are talking, and who is the observer. Okay, whether you are talking from observer frame of reference or from your end point of view, or spectator, I mean observer or spectator, however you call it out. Okay, whatever you call it, the names can be different but the concept remains same. Clear? Now let us see couple of scenarios, where you will further get this understanding. Okay, now okay, let's say I have a bike. Okay, I am here. Okay, I am on the ground. Okay, I have a bike. Okay, a bike is traveling. Forget about the drawings and all. A bike is traveling. Okay, now this is B, now this is A. Bike is traveling with velocity 10 meters per second. Okay, I am stationary on the ground, I am not moving for a second. So what is velocity of A with respect to B? Is nothing but VA minus VB. What is VA? VA is nothing but velocity of A with respect to ground. Correct? Velocity of A with respect to ground, which is nothing but 10, minus velocity of B with respect to ground. What is velocity of B with respect to ground? I said I am stationary, therefore it is 0. Therefore relative velocity of A with respect to B is 10. Okay, similarly, in the same concept, assume I am also traveling with respect to 10 meters per second. Okay. Let's say I am also traveling with 10 meters per second. So what is relative velocity of A with respect to B? It is nothing but VA minus VB. Correct? What is VA? Velocity of A with respect to ground. So VAG minus VBG. Correct? Velocity of A with respect to ground is 10. Earlier we have seen. Now what is velocity of B also with respect to ground? In the second scenario I have told it is 10 meters. Correct? So it is 10. Therefore 0. Therefore the relative velocity of A with respect to B in the second scenario is 0. Why? Why? Simple. He is also traveling with 10 meters per second. I am also traveling with 10 meters per second. I do not see any difference, because from my reference point of view, I am also traveling at 10, he is also traveling at 10. So therefore there is no difference in velocities, or there is no relative velocity at all. Both velocities are same, therefore it is 0. Clear? Understood? Now in the similar sense, let's say I am here. Let's say I am here. Okay. I have an other person who's traveling. Velocity is 10 meters per second. Okay. This is observer B. This is observer. Sorry. This is observer B, and this is A. Now my velocity is 20 meters towards this side. Okay, my velocity is 20 meters. So what happens? As simple, I am the B is observer. So velocity of A with respect to B, velocity of A with respect to B is nothing but velocity of A minus velocity of B. As simple as that. Velocity of A minus velocity of B, which is what? Velocity of A with respect to ground is 10 minus velocity of B with respect to ground is what? 20. Correct? That means it is minus 10. Now what does this minus 10 indicate? So therefore my relative velocity A with respect to B is nothing but minus 10. What does this minus 10 indicate? That means what? The moment I am sitting in B, that means the moment I am seeing B. So let's assume we both are traveling in straight line. Okay, the moment I am B and I am A, the relative velocity, if it is minus 10, that means what? I am traveling faster. And it will seem as if it will seem excuse me, if it will seem as if A is traveling back, because when I say minus 10, the direction is this side. Correct? It will seem as if A is traveling back with a velocity of 10 meters per second. Why does that happen? Because I am traveling with 20, he is moving with 10. Therefore you will feel as if okay, minus 10, you will feel as if he is traveling back. You will feel as if he is traveling back. Okay. Now similarly, the other scenario is, let's say I am B. Okay, and he is A. He is traveling this side with 10. I am traveling. This is B, this is A. I am traveling on the opposite side. Okay, I am traveling on the opposite side. 20 meters per second. Okay. Now what will the velocity of A with respect to BB is nothing but VA minus VB. So which is what? VAG minus VBG. Correct? VAG minus VBG. What is velocity of A with respect to ground? 10. What is velocity of A with respect to ground? It is 10. A is moving 10 towards right. Now what is velocity of B with respect to ground? It is nothing but minus 20, because it is traveling in the opposite direction. Velocity being a vector, direction is important. Therefore your relative velocity VAB is nothing but 10 plus 20, 30. Okay, relative velocity of A with respect to B is 30. What does this indicate? That means what? You will feel, because the velocities are in opposite direction, velocities of this is in opposite direction, you will feel that, because from the reference point of view, if I am sitting here, you will feel that A is moving this side with a velocity of 30. Why? Because already I have a velocity in the negative direction of 20 meters. Okay, so if a fly is sitting here, let's say if a fly is sitting here, okay, if a fly is sitting here, because it will also have a same reference of velocity, it will have 20. So it will feel as if A is moving towards the opposite direction with a velocity of 30 meters. Clear? Understood? Now, okay, these are a couple of scenarios that we have seen. Now you can have multiple scenarios in this. Now let's see one more scenario. Let's say okay, let's say the bus is traveling. Okay, let's say the bus is traveling. I am sitting here. Okay, and on the bus there is a, you can call, I mean this can be bus, train, whatever you call it. On the bus or train there is another person. There is person A, this is person B, and this is let's say this is S. Okay. Okay. Now velocity of S is nothing but 10 meters per second. Okay. Now velocity of S is 10 meters per second. Okay. Now for a second, let's say the velocity of B is 0. The first scenario is velocity of B with respect to ground is 0. Velocity of this bus, velocity of this bus, let's say Vs with respect to ground is 10. Correct. Now, if velocity of A, the person A who's sitting here, is 0, he is stationary. That assume that he is not moving anything. So, what will the velocity of relative velocity of A with respect to B be? Velocity of A with respect to ground minus velocity of B with respect to ground. Correct. Now, what is velocity of A with respect to ground? What is velocity of A with respect to ground? You do not know. Correct. You will simply say. You will simply say. Let's take this thing here. You do not know. You know that velocity of A with respect to S. Velocity of A with respect to S is Ag minus velocity of S with respect to ground. Correct. What is velocity of A with respect to S? What is velocity of A with respect to S? It is 0. Why? You are stationary because this is not moving. So that means I will assume that whatever is the velocity of S, it will be the same velocity of this. Correct. So therefore it is 0. My VAG is nothing but same, that is what I am supposed to find out. SG is 10 meters, so this is 10. Therefore my velocity of A with respect to ground is 10 minus velocity of B with respect to ground is 0. Therefore velocity of A with respect to B is 10. Velocity of A with respect to B is 10. Similarly, if I ask you what is velocity of S with respect to B, it will also be 10. Why? Because the frame of reference of A and S are same. Because the frame of reference of A and S are same. Okay, understood? Now to slightly complicate this, okay, let's say velocity of A is 2 meters this side. Let's say velocity of A is 2 meters per second towards that side. So what will happen? What will happen? What will happen if I am asking you to find out velocity of A with respect to B? I will simply say velocity of A with respect to G minus velocity of B with respect to G. Correct? Now, but in this case, do I know velocity of A with respect to ground? No, I do not know. I know that velocity of A with respect to S is nothing but 2. Velocity of A with respect to S is nothing but 2. So, you will similarly do this equation and find out. So, velocity of A with respect to S is nothing but velocity of A with respect to ground minus velocity of S with respect to ground. What is velocity of A with respect to S or this bus? It is nothing but 2. Therefore, 2 comes here. Velocity of A with respect to G is you are supposed to find out minus velocity of S with respect to ground is 10. Therefore, VAG is nothing but 2 plus 10, 12. 2 plus 10, 12. Therefore, now you do this. Velocity of A with respect to B is nothing but velocity of A minus velocity of B. What is velocity of A with respect to ground? From this we found out it is 12. Velocity of B is nothing but 0 because it is at rest. Therefore, velocity of B is 12. Clear? Now just to add more complexity to this. Just to add more complexity to this. Now if I say my B is also moving with respect to 5 meters per second. So that means what is velocity of A with respect to B? It is nothing but velocity of A with respect to ground minus velocity of B with respect to ground. Now I have told you B is also moving with respect to 5 meters per second. What happens? Velocity of A with respect to ground is 12 minus velocity of B with respect to ground is what? 5. Therefore this becomes 7. Clear? Understood? So velocity of A with respect to B is 7. In case all three are moving, that is bus is moving with 10, the person A is moving with 2, person B is moving with 5 on this side. Now all the observer points I have taken with respect to B. All the observer points I have taken with respect to B. Okay, all the observer points I have taken with respect to B. Now similarly, if you just change the observer, so instead of B, if I ask you A, what is velocity of A, sorry, what is velocity of B with respect to A, it becomes velocity of B with respect to ground minus velocity of A with respect to ground. Concept remains same. Okay, the concept remains same. Which observer, which frame of reference is all what you have to do. So velocity remains similar. Okay, velocity remains similar. Okay, all you have to do is check which observer and which frame of reference that you are taking. I can have multiple hundreds of questions on this. Okay, so similarly, let's say I mean one simple concept I'll tell you. One simple concept, let's say I have a person here. Okay, okay, I have a bus here and I have a person on top of the bus. Okay, bus, this is C, this is A. Now I can have frame of reference with respect to C. I can find out what is the velocity of A, velocity, that is I'm saying relative velocity, relative velocity of A with respect to C, relative velocity of A with respect to B, sorry, A with respect to C, correct. Now similarly, if I change the observer, if I am finding if I am changing the observer of A, that means I will find out velocity of C with respect to A, velocity of B with respect to A. Okay, now if I change the observer again, I keep the bus as the observer, I can find out velocity of C with respect to bus, velocity of A with respect to bus. Okay, all the scenarios you can have multiple scenarios, whereas the concept remains same. Here in the first thing, if I am finding out velocity of A with respect to C, it is nothing but velocity of A minus velocity of C. If it is velocity of B with respect to, sorry, this should be it is velocity of B with respect to B. Okay, so here it becomes velocity of A minus velocity of B. Clear? Now velocity of, if I am taking the reference where observer point of A, if I am taking observer point of A, this becomes velocity of C minus velocity of A. Sorry. Okay. Okay. Observer. Now this becomes velocity of B minus velocity of A. As simple as that. You can have multiple equations, multiple velocities coming up. All you have to do is fix the observer, fix the frame of reference. From which frame of reference and from which observer you are observing. So then it is simple. VA minus VB is velocity of A minus velocity of B. What is VAB? Velocity of A from the velocity or the observer's point of view of B. Clear? Understood? Now, to add one more complexity in this, let's say it's a simple concepts only, but as you see the complexity increases. Okay, you can have different scenarios. Okay, let's say I have a car. Okay, you have a car here, and I have a bus or a train. Let's say I have a car, I have a train, I have a person running on this. Okay, I have a person running on this. Let's say this is person A. Okay, and I have another person on top of the car. Okay, on top of the car B. Okay, now I have velocity of train with respect to ground is 10 meters. Okay, now the person on top of train is moving with 2 meters per second. Okay, person on top of the train is moving 2 meters per second. Now this car is moving with a velocity of 5 meters per second towards this. Okay, and this person on top of the car is running with again say 1 meter per second. Okay, now you've seen, firstly when there were only two persons, we only had two velocities, either with respect to A or B or B or A. Now as we have seen, we have increased one more, that is in the previous case we have seen one more reference frame, so that means you have got six velocities. You can have six velocities. Now similarly in this you can have a frame of reference of A, you can have frame of reference of B, you can have frame of reference of car, you can have frame of reference of train. Okay, all this you can find out, and with a simple relative velocity concept. Okay, now if I am asking you to find, the relative velocity of A with respect to B, relative velocity of A with respect to B, all you have to do is relative velocity of A with respect to ground minus relative velocity of B with respect to ground. Clear? This is the fundamental equation. Now do you know relative velocity of A with respect to ground? Do you know relative velocity of A with respect to ground? Do you know it? No, because relative velocity of A with respect to train is nothing but relative velocity of A with respect to ground minus relative velocity of train with respect to ground. What is relative velocity of A with respect to train? Just 2 meters. Okay, A with respect to ground is what you're supposed to find out. What is relative velocity of T with respect to ground? It is given 10. Therefore, your A with respect to ground becomes 12. Okay, so this is 12. Similarly, what is relative velocity of B with respect to ground? You are supposed to find out, correct? You know that relative velocity of car, relative velocity of car is nothing but relative velocity of B minus relative velocity of car with respect to ground. What is this? This is 1. What is relative velocity of B with respect to ground? You don't know. What is relative velocity of car with respect to ground? It is given 5. Therefore, VBG is nothing but 1 plus 5, 6. Therefore, here it is 6. Therefore, relative velocity of A with respect to B is 6 meters. Relative velocity of A with respect to B, okay, is 6 meters. Now if you understand the difference, you will understand that relative velocity of A with respect to B, okay, relative velocity of A with respect to B. Clear? Understood? Okay, this is traveling on a bus with respect to 10 meters per second. Now B is on a car, the person B is sitting on a car who is moving with relative velocity of 5. Okay, clear? Understood? You can have multiple scenarios, multiple concepts on this. Okay, as and when you see the relative velocity, just fix up the frame of reference and observer. That's it. From there you start off. Clear? Now, in all this, if you've seen, we have talked about relative velocity, relative acceleration, relative displacement. Now, in all of these things, what is the one thing that remains constant? The one thing that remains constant is nothing but time. Okay, there is no concept of relative time. Okay, so let's see, if A is moving this side, in the same time B is also moving, say example, in 5 seconds A is moving from this point to this point. Okay, in the same 5 seconds B will also move some distance. With respect to his velocity, etc. So do not underestimate the time concept. Okay, do not underestimate it. Don't think that there is a concept of relative time as well. No, you have relative acceleration, you have relative velocity, you have relative motion, but time does not change, because for everyone there is some amount of time that takes to cover that velocity or acceleration or displacement or distance, whatever you call it. So time is always constant. Clear? Time is always constant in this, and the only thing that changes is your displacement, your acceleration, your velocity. Why is this happening? Because of motion. Because motion is relative and time is constant, you have all this observer frame of reference, you have different frames of reference wherein you see different relative velocities or different accelerations coming. Clear? Understood? Now tomorrow we will see couple of problems on this relative acceleration, relative velocity concept. Okay, now go through this. For any further questions, please do ping up. I hope you've understood the concepts. All these are fundamentally important concepts, simple ones, important ones, and interesting ones. Okay, the moment they give a question, you can definitely, this is like I've told you, all the questions in a motion straight line, all the questions in kinematics, etc., are boundary balls. The moment a question paper is given to you, you are supposed to search for these questions attempt it, answer, and then go back to the next question. Okay, clear? Thank you for this. Do check out our Spark videos in other topics as well. Do join us for further more interesting concepts and further more interesting problems. Thank you.